Good morning. Today we are going to talk about how to convert a system of equations into matrix. Let's start with the following example. Assume that we have a number of equations with n variables. Say with respect to question number 1, a11 x1 plus a12 x2 plus a1n xn equals d1. Second one, a21 x1 plus a22 x2 plus a2n xn equals d2, and so on. The last one, am1 x1 plus am2 x2 plus amn xn equals dn, where n is the number of x's or columns. Now we would like to convert this system of equations into matrix. We can read this matrix as, for example, A12, which means this is the first this is in the first row, second column. Okay, so these numbers refer to the location or the place of the element in the matrix. Row number 1, column number 2. This is row number 1, column number 1. So we can convert this system of equations to the following matrix. We are going to collect all A's into one matrix A and all X's in one vector X, and finally all D's in one vector D. So we can write this system of equations into the form AX equals D, where A is a matrix and X and D are vectors. So we can write this as follows: A11, A12, A1n, A21, A22, A2n, AM1, AM2, AMN. This is matrix A. And with respect to X, it is a vector. Consists of x1, x2, xn. And finally, with respect to D, it will be a vector, d1, d2, and dn. Now we would like to use matrix notations in order to solve this model, or to find the answer for the value of x1, x2 till we reach to xn. So returning back to the equation AX equals D, we would like to find the value of x if it's not a matrix notation. So we are going to divide both sides by A. So it will x will be D divided by A. But in case of matrix notation, we cannot divide by a number, but we can find the inverse of the matrix function. So we are going to multiply both sides by the inverse of matrix function. It will be a to the power negative 1 ax equals d a to the power negative 1. This is the matrix multiplied by its inverse is the identity matrix, which is equivalent to 1. So we can say that the value of x's can be determined by multiplying the inverse of the demand function by the vector d. Let's take an example for a system of equations: 6x1 plus 3x2 plus x3 equals 22, x1 plus 4x2 minus 2x3 equals 12, 4x1 minus x2 plus 5x3 equals 10. So we can convert this system of equations into the following form: 6, 3, 1, 1, 4, negative 2, 4, negative 1, 5 equals x1, x2, and x3 equal 22, 12, and 10. So now if we would like to find the value of x, so we have to find the inverse of A, matrix A, multiplied by D. Okay, let's review how to get the inverse of a function, of a matrix. The inverse of a 3 by 3 matrix In order to get the inverse of the matrix, there are a number of steps. Step number 1 is to find the determinant. In case of 3 by 3 matrix, determinant can be determined as, this is the matrix by the way, okay, we would like to find the determinant. Determinant will be written as six multiplied by, and then we are going to neglect this row and this row. So it will be calculated as 4 multiplied by 5 minus negative 2 multiplied by negative 1. And then we are going to move to the next element. It can be 3 or 1. You have to determine it by yourself. So we are going to take this element, 3. So it is minus 3 multiplied by, now we are going to cancel this row and this column. So it will be 1 multiplied by 5, it's like cross multiplication. 1 multiplied by 5 minus negative 2 multiplied by 4. Then we are going to move to the third one. It will be plus 1 multiplied by, now we are going to cancel this column and this row. So it will be 1 multiplied by negative 1 minus 4 multiplied by 4. So this is the determinant in case of 3 by 3 matrix. So we can write it as 6 multiplied by 4, negative 2, negative 1, 5, like small determinants, negative 3, we can write it in this form or in this form, it doesn't differ. But the final answer at the end is the same, which is 52. So the determinant of this matrix is 52. Second step, find cofactor matrix. Return back to our example. This is the original matrix. Now we would like to find the cofactor matrix. Cofactor matrix are going to be defined as, with respect to the first element, going to be replaced by 4, negative 2, negative 1, 5. Second one, 1, 5, 1, negative 2, 4, and 5. And finally, with respect to the third element, it will be 1, 4, 4, negative 1. We are going to do the same for the 3 rows. So we have to calculate the cofactor for each element. Okay, once again, with respect to the second one, the original matrix is so with respect to this one, we are going to cancel this row and this column. So it will be 3, 1, negative 1, and 5, 6, 1, 4, and 5, 6, 3, 4, and negative 1. Okay, with respect to the third one, it will be 6, 1, 3, 4, 1, negative 2, 4, negative 1, 5. We are going to cancel this row and each column. So with respect to the first one, it will be 3, 4, 1, negative 2. The second one, 6, 1, 1, negative 2. And with respect to the third one, it will be 6, 3, 1, and 4. Now, just like the calculation of the determinant, we are going to multiply 4 multiplied by 5 minus negative 2 multiplied by negative 1. For each one of them. So the cofactor matrix will be 18, 13, negative 17, 16, 26, 18, negative 10, negative 13, and 21. Now we are going to apply sign rule. It will be positive, negative, positive, negative, positive, negative, positive, negative, positive. So the new matrix will be 18, negative 13, negative 17, negative 16, 26, negative 18, sorry, this one is initially negative, so it will be negative, negative. This is positive 18, negative 10, 13, and 21. So this is the cofactor matrix. Then step number 4, adjoint matrix. So we have to convert rows to columns and vice versa. As a result, it will be 18, negative 13, negative 17, negative 16, 26, and 18, and finally negative 10, 13, and 21. Finally, the last step is to find the inverse, which is calculated as 1 over the determinant multiplied by adjoint. As we said that the determinant is 52 multiplied by the adjoint matrix, which is 18, negative 16, negative 10, negative 13, 26, 13, negative 17, 18, and 21. So now we can write the inverse as 18 divided by 52, negative 16 divided by 52, negative 10 divided by 52, negative 13 divided by 52, negative 17 divided by 52, 26 divided by 52, 18 divided by 52, 13 divided by 52, and finally 21 divided by 52. This is the inverse matrix. We would like to use the inverse matrix in order to find the value of x, x1, x2, and x3. And as we said that we have to multiply the inverse by the vector d. So using the inverse function, the inverse matrix, which has been calculated and so on, and multiply this by 22, 12, and 10, we can get the values of x1, x2, and x3. Okay. So now we are going to take this row and multiply it by this column in order to find the value of x1. So the value of x1 will be calculated as 18 over 52 multiplied by 22 plus negative 16 over 52 multiplied by 12 plus negative 10 over 52 multiplied by 10. And we are going to do the same with respect to x2. So we are going to multiply this row with the same column. And with respect to x3, we are going to multiply the last row with the D column. Okay, this is 3 by 3 matrix and this is 3 by 1 matrix. So we are going to get 3 by 1 vector. So the values of x1, 2, and 3 will be 2, 3, and 1. So the final answer will be 2, 3, and 1. This is the end of our lecture today. Thank you.